Halo Pak.
Halo, selamat siang ya Pak.
Ya silahkan bisa dimulai. Bapak mau share kamera atau share screen?
Ya Pak, saya langsung aja. Jadi, selamat siang. Assalamualaikum warahmatullahi wabarakatuh. Pak, terima kasih saya ucapkan khususnya kepada PT Piranti Sarana Elektronik ya, selaku konten. Kebetulan kami permohonan maaf dahulu dari Kepala Balai kami, Bapak Cakra Nagara, beserta pejabat struktural, karena kebetulan pada hari ini dan sini untuk Kementerian PUPR sedang ada pelantikan pejabat fungsional, Pak. Jadi memang pada saat ini organisasi dengan jabatan kerja yang baru, dengan struktur yang baru, nah efektivitas organisasi sehingga baru sempat pada hari ini sedang melaksanakan pelantikan untuk jabatan fungsional tersebut. Jadi seluruh Indonesia saat ini Kementerian PUPR sedang melaksanakan pelatihan. Izinkan saya sampaikan permohonan maaf kami selaku perwakilan dari Balai Penerapan Teknologi Kementerian PUPR tidak bisa resmi secara langsung dari Bapak. Ya. Yang pertama saya sampaikan terima kasih juga kepada PT Piranti Sarana Teknologi ya, bekerjasama dengan Balai Penerapan Teknologi Konstruksi untuk bisa menyelenggarakan kegiatan ini. Mudah-mudahan dalam beberapa rangkaian kegiatan kali ini yang sudah kita mulai dari hari Senin kemarin dan akan terus berlanjut sampai dengan hari Jumat, dan beberapa topik yang sangat menarik menurut kami, dan apa yang bisa capai pada kegiatan kali ini bisa membawa manfaat bagi kita semua, khususnya para peserta dengan langsung. Mungkin demikian sepatah dua patah dari kami selaku perwakilan dari Balai Penerapan Teknologi. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk kita semua. Om Swastiastu, nama budaya.
Okay. So, good afternoon all.
Yes, I think so.
Okay.
Yes.
So, my name is Ramon Steins from Sales Enablement Department webinar, and sincere apologies for the technical problems we encountered. Now it's all good, so now we can introduction of the position of ALLPLAN within the name check. What is the group above all? Repeat that, but what I want to do is look a little bit back on what we presented yesterday and give we didn't put that much weight. Parametric building elements also included in ALLPLAN.
Berantakin kasarnya bunda. Dalam saya. Bahasa Indonesia. Bahasa Indonesia.
The presenter Van Binnemans will also be the one who presents the bridge solution today. With that bridge solution, we brought something to the market what was not existing, so it's a real unique. So actually, this is the point that I think to introduce him again. He's a very experienced ALLPLAN consultant and specialty is in bridges. You see Ralph Pullinger also listed on this slide. He will be the one who takes and he will assist in some workflows also, Stefan. The control, or maybe Ulrich can do that. And I
Okay, you can all see my screen.
Yes.
yes.
Okay, let's start PowerPoint. They will be a little bit different. Yesterday, I will start with a longer PowerPoint view of what the possibilities are of ALLPLAN Bridge for modeling and analysis. It's quite extensive, some slides and short movie clips. After that, we will dive into ALLPLAN Bridge and do an introduction. This how you work in ALLPLAN Bridge, what the parameters are, what the links are between different elements, and we will do that with the getting started example is included in ALLPLAN Bridge, so it's easy for you to start with and resolve also many of this example. After that, show exactly all to create your parametric bridge model. And as a last point, we for a finished bridge model, that means you have a parametric model generated in ALLPLAN Bridge. What does it mean in ALLPLAN if you do for visualization purposes where you have a dressed up bridge model? And for this, I will be using a project that we also showed yesterday at the bridge. So we'll continue now with the PowerPoint. Just to check, can you see my whole screen? The top right?
Yes, we can, Stefan.
So everything is okay?
Yep.
Yeah. Bridge. What is ALLPLAN Bridge exactly? Where you can do the design, the analysis, and then detailing in the link with the ALLPLAN engineering in one solution. So it's a whole portfolio. It's fairly new software. It means it's very exciting because it advances quickly. It was released ago in April, and at that point you could do parametric modeling, and each 6 months there your bridge analysis. Of course, there will be a new release with ALLPLAN 21 also in October, and new exciting things will be included. So we see there is a really big improvements or additions going on because it's new software. A lot of things can be added, and it started with modeling, and still modeling is improved. New functionality is added each release, so it's going quite fast. That means if you work with ALLPLAN Bridge a couple of months ago, some new things will be there, and many new things, many exciting things are getting possible also in the near future. When we talk about BIM for bridges, ALLPLAN also is working on including BIM for infrastructure, which is then included in IFC 4.1, if I'm correct. So they're working on that in one of the future releases to implement that. Now, if we talk about BIM for bridges, we could do with ALLPLAN Bridge already the parametric modeling. We have the construction stages that can be generated. So you have some visualization, you can set this up, we'll show this later also. Analysis model. Then we have the analysis results that can be calculated. Also with the link with ALLPLAN, we can do the reinforcement detailing. And there is one check which now has been included in the -1 release in April, is then the reinforcement design and checks. Okay. Now for modeling advantages, so when you model, how does this parametric modeling work? Very basically, you have a cross-section, which is the profile or the cross-section of your bridge, and you have an axis, and everything is modeled along this axis, let's say. You can define then variations for your cross-section. So you can have a variance. You see here, for example, the bottom of the deck. The cross-section is being generated along the axis, but you can set variations for your different variables. So you can control, and this is done in a very nice way. Step by step, you can introduce new complexity to your bridge. You don't have to start with finalized design. You can start with a very simple cross-section and then add variables to it, add variations to it. So you build and gradually get a more complex model as you design it. So you design as you go step by step. So you have full control over it, and it's very transparent also what happens. Some examples we see here, and with this approach, many different types of elements can be generated. So different types of bridges can be generated. Also, piers can be generated. You see here on the right-hand side, so the same principle appears on a vertical axis, where you model with the same cross-section principles and variation principles. So these principles will be carried along the general workflow in ALLPLAN Bridge. So if you understand how this principle works, it's easy to learn also and get deeper into the software. So we have a geometrical model, and from this geometrical model, which is generated by parameters, other things can be derived. You can create a construction sequence from it. You can send it to ALLPLAN and then do some do the final detailing. But it's all based on this parametrical model. You see here that when you change, for example, the axis, your tendons will also be regenerated. So it's something that all parameters are linked together with tables. These variations that you see here, you modify something, the bridge deck will adapt to it. Your analysis result will adapt to it. The geometry that will be sent to ALLPLAN will adapt these changes. So you control fully by these parameters. You can see you can make the deck a little bit wider. You can add a parameter to it, so the width can also be then generated or handled by variations and parameters. Also for other components like a railing and a guardrail, you can add to a bridge deck as an additional component, for example. What is also possible is with a link with ALLPLAN, you can have your library, let's say for bearings, then bearings, lampposts. This is something I will show also in the last example, and you can add them to your bridge deck with the same principle of these variations, where you say, okay, at this point I would like to have a bearing, at this point I would like to have a lamppost. These are parametrically positioned in ALLPLAN. So if you go to, in ALLPLAN Bridge, so if you go to ALLPLAN and then you update your model, you will see that every object that has its origin in ALLPLAN Bridge will also be modified. So for visualization purposes, this is also important. If you change the axis of the bridge, for example, modify anything, then will be added parametrically with this library. Smart symbols will also be updated. So they just are placed by ALLPLAN Bridge. For the tendon generation, so grid, so you can define a grid, and each of these points can then be a reference for a tendon. With these grids, and then define how they need to be used with offsets and different settings to the grid. And geometry by variation tables. So you control of the tendon. So here you can see it's just being copied along these tendon grid points. If you change, be regenerated and recalculated. So now there is no need to set any tendon because they follow their parametrical grids. Then the geometry can be checked, and here you get the losses calculated. So you get a typical diagram where you see the optimal stress being displayed, but also with the slip that you have in the beginning, or if you stress it on both sides, you get different values being calculated. So you get from the tendon being stressed for one or both sides, you get a diagram that clearly shows what is happening calculated. For a cross-section, these cross-sections, they can, from scratch, you can also say, create my own library, so you can easily reuse them again. Section, but has a lot of parameters. That means all these parameters can be variable. So you can say, I have a typical cross-section, but that you can still to make it possible to have many different types of the same typical cross-section. Also, for example, steel cross-sections, there is a possibility to add the stiffeners, and this is a system that can objects where you define, let's say, subcomponent, and the subcomponent can be used and then be placed as a kind of instrument. You have an edge and you place it along the edge. Here you can see that you can place any type of object, like a stiffener in this case, along parameters, so you don't have to define each one individually. It can just populate this edge of this boundary. Also in 3D model, like you see here. So that makes it intuitive and very quick. Also examples of these possibilities of referencing another cross-section. So for the bridge equipment, like the side, you can take them from another cross-section and then insert them in the existing model, also like a barrier. So it's possible to design it before, so you don't need to do this each time again, and you can take these basic components as a part of a cross-section and add. Same thing for girders, elements. You have your cross-section, define it, and then place it, and then if you update one in your existing cross-section easily. Also possible for really a complex supporting arc is actually also following this principle, where you have an axis, main road axis, but from which is in top view can be a radius here also, and also from the side view you have another radius. So it's possible to generate multiple radius. That means you don't have to define all the parameters, because this could be a parameter where you say this is the meter, but then you need to define all these parameters. It's possible, but you can also say, no, this is just an axis that needs to be followed to the side. So everything or lines will be linked to this axis. So this is also something that adds a lot of flexibility for this complex element. Then we can define construction stages. So if you model your parametrical bridge model, you can then define, and this can be done for modeling only. So if you go to ALLPLAN, then you can see these different element settings, for example. Here you can see some kind of flow through the process where the different stages are being. For this, these construction stages can also be used for analysis. So if you have a specific construction sequence, then this can be. Oh, thank you. About the analysis advantages. So Allplan Bridge started with modeling first, then tendons were included, then analysis, and also the overall analysis, live loads. So things are being added to make this analysis. Okay, so this is all in one. When you define your parameter, or the same parametrical model will be used for the analysis model. So that means there is no double modeling. The same parameters will be used. You can use the same reference point to define your geometry for your supports on the piers, for the ability to define the loads, etc. So everything comes from your parametrical model type of model. For the cross sections, so you have your bridge model, which has, it's as you calculate all cross section, each variation of the cross section for each point in section properties will be calculated automatically. Here for the construction sequence, what this can do, and here you can see then a simulation where also the analysis is being included. Cantilever direction, and then you can see this forces being displayed. Also possible with this is that you have multiple construction variants. So depending on the you choose, you can have variants where you can compare with each other. So let's say if you choose one variant, you can simulate it, or you can have another one which can have a different order, and then you can compare them with each other. Alternative or variant construction stages from one model, and then compare the results and do some optimizations. Create a section. You can have in your cross section defined elements which are then the actual additional elements which are just generating a load. So it's not part of your structure for the analysis. It's just a load put on top of the bridge. And this is also done when you create the cross section. You can define this element, this. But also, for example, in your construction sequence, where this load will be then set. In time, you see here a sidewalk, for example. This is just load that will be added to it. In the cross section, with then the general members, and the green is then what would be the additional that loads being added to it. So again. And then for analysis, the same information will be used. Then we have different cases, and you can add this in an intuitive way, like visual scripting, like where you make these nodes, connect them. The worst case state will be used in the final analysis, for example. Or this table or this canvas for other projects also. Flowcharts, how this combination should affect and how they have to be used, and it gives you a very good overview. Presenting of the results, so for the analysis, based on your 3D model, and then you can activate the information, for example, depending on the different envelopes that you have defined, like temperature or wind of the loads, for example. And then you can also define with color coding by the surface, or also you can choose which one you would like to see, what combination you would like to see, if you would like to see multiple of them, one next to the other, of this representation. And it's also possible to export, where you see then the result, and can export this also to Excel, for example. So possible depending on the type of result you would like to see or visual. Let's go ahead a little bit. So different combinations there, and here you can see that you can do it in a table representation view of these results and can use them somewhere else. So this is the final slide. You have one single model, one single source of truth, and then this means you have your parametrical model defined and be used for structural analysis, because the analysis model is part of it, and you can also use it as a detail can be sent to ALLPLAN engineering, where you continue adding information to it, like reinforcement, for example. To start is the parametrical model that can be used for different purposes. If something changes with the parameters, all models will be count this new design or the changes in the design. Okay, that was it for the PowerPoint. Step would be to dive into some examples. So,
okay, to interrupt you just for a second.
Yes.
We were wondering if you are doing some Q&A at the end.
Also,
okay, so Siswante would just collect some questions and maybe ask them if we have time enough at the end.
Same format as yesterday. We will have more time today than yesterday for the questions and the final wrap-up.
All right, thank you very much.
Yes. So when you start ALLPLAN Bridge, you will be greeted with this welcome screen, and there are examples, and this is very interesting if you want to get into the software. Types of combinations with different types of designs, and each of them has something integrated where you can experiment. Small explanation. And here for this getting started example, there's also actually a PDF manual included with all the steps to create this from scratch. Try out something by yourself. This is a very good way to create your first model. It includes many steps. The setup of the parametrical model, and also goes into analysis. So we'll start with this example. And this is a concrete bridge with tendons. So here you can, with the color coding for the different types of elements, you can see the tendons also. And put this here. Okay. So with the interface, you have the different task areas that you have, and you have then a palette where you navigate to different parts of your wall. There are different ways to visualize also something, depending on that have been defined. You can also say, okay, this is like now we see concrete texture, for example. So there are different ways to set this up. Steel can look differently, different visualization possible, types possible here. So what do we have here? have a bridge with two piers. We have tendons. We have actually a different. There will be one phase here, another phase. I think there will be 3 phases. So this is just this getting starting example has we'll do how we can create a model like this from scratch. So we are here in geometry, the structure to what you have, the structure in ALLPLAN. And we see here the main elements. We have axis definition. So axis is a geometric element. You can see this here in red color. Sections, multiple for the pier, for example, for this one here, for the main girder. We have variations, tables, for example, how the height of this bottom of the deck should be varying. You need to have axis cross-section, yes, but variation tables or the variation is something that you can define if you need one. And then the 3D objects themselves. So you have an axis defined, you have a cross-section. Together, you generate your 3D model. In this 3D object, let's say main girder, you have still all definitions from cross-section and axis. So if I'm typically, the stationing is what you have here. You see 0.5 meters. This is the stationing aligned by the axis, because you can, in the main girder itself, you can define, or when you create it, and afterwards also you can define additional, not limited to the stationing you have in your axis or in your profile. So it gives enough flexibility to add stations. By the stations, so these are all the stations being used, so you can just add a new station somewhere if you need it. You can also see in light it, for example. Cross sections, you will see here what actual cross section and what variant it generates. Yes, so you get an overview from this is this main girder. And there are the variation tables, different parameters being used. And then at the end, the third one here, you have an overview of all the variables. So we have, for example, web width, and then we see that it varies. You have the thickness of the bottom. We have the height. So there are different tables. I will show later where this exactly comes from. But you have the stationing along the axis. You have a cross-section, which is a view of what variation actually is being value, where you see actual for the piers, the same thing. You have the stationing, cross-section, variations. Now if you go with the axis, for example, so we have our axis. How is the axis defined? Then you will see the elements that have built up this axis. So you have a starting point, we have a first segment, which we have then a spiral or clothoid with this specific definition. So it starts at 0, the parameter at the end, curvature, and then we have here a radius. These are parametrical elements. That means I can change 200. And then you will see the axis being changed from minus 200 this way to 200 going this way. So if I regenerate my model, then you will see that everything will be recalculated. Like at this point, I've also set the analysis model to be recalculated. You can just choose, I just want to the geometry and don't want to update the analysis results, then you can also set this. So here now we see that the bridge has changed, but the super elevation at this point is not right because it is for a turn that goes the other way. Okay, you can set this individually. If you want, you can also link different parameters with each other. Maybe at this point, because I checked for the analysis model, we can also go to the results, for example, of the cross section, and we have the different variations. And if I check here variation, then you will see this display of the cross section. Yeah, so you get this here for each different variation. Then you can see clearly also what how the super elevation change place changed. So you see it very well which one you're being used in here in 3D model, and you get the results right. Okay. So let's do other update. I will first generate the geometry again, maybe change the axis back to its original value. Oh, no. Yes, so -200, enter, and then we can see this being original situation again. At the same time, we have the profile. So the profile is along the length of the axis. It's 150. Set a point, and then by a tangent or by a radius, you can set also how this curve should be cut. See, a rounding type is being applied with a radius to generate this curve. So these stations are actually generated to have them here in the axis, for example. Okay, then for the axis and profile, together they form your 3D axis. Okay, so I will do also with analysis result. Then we will go into some analysis display, like you've seen in the PowerPoint, changing some modeling parameters, where we change, for example, in the cross section, the main girder box. See heights, for example, super elevation, and then we'll take a look at the variations and how exactly they. So if you check the results, for example, you can choose to highlight different. So let's see if I have my analysis. There, yes, okay. So we have 3D model, analysis model. So depending on what you choose here, you will get a different part of your model and different visualization. So, for example, here in the bottom, I would like to see for the wind loads, for example, wind, different types of with traffic, for example. So you can highlight it. I don't want to see the diagrams, for example. I would like to see the what case you would like to have, and then you can visualize these different parts. Okay. Up again to so we have here with the tendons, wind, so different types of elements that you can visualize. You would like to see, for example. And then depending on the diagram you activate, you will see some. Yes, so you have full control over the different different parts, and you can just activate which one you would like to see. Okay, so here you can see, for example, the deformation, also you can play with these values to see exactly how it's represented. And then you can see, for example, I don't want to see the deformation type for wind, for example. So you can choose what elements you would like to see, how you would like to visualize it to give you a good will be happening in your model, and compare the analysis results. Okay, so the geometry. So we've seen axis and plan. Yes, and then next step would be taking a look at the cross main girder box. You can choose any type of name you would like. And here we have all the different elements that are defined. We have then the additional elements being added to it, like a barrier, for example, which are not part of the structural. Everything is defined by reference points and parametrical lines. So you see here these gray lines. Parametric control how this section behaves. For example, the one here in the bottom, if I click on it, you can see distance. And now if you change distance, you see what happens here. The web on its own orientation, but the main girder will become higher. So the cross section will become higher. But if you see also in the bottom, smaller or less wide, because of the angle of the web is fixed. So you can define this also how the. If I click another line, then here you will see now that the thickness of the bottom can be controlled, but then also the with it parameter, and you can link another line to each one. So again, if I change this one here, you can see just follows this main line. That means this one is linked, and you can see it in the preview also. This line is linked to this line. And we see also that this line, the axis, so that means if the bridge goes up and down, this will follow, of course. Other example here is the inclination for this line. And then you can see that I can change the angle, and now I have control. And what is special here, this part where you have the barrier is not influenced by it. It has a fixed angle. So if I go, part of the deck will change, but this one is a fixed angle. So again, you can define a relation between a line, which will probably in this case, and this follows this point. So if this moves up, this angle stays fixed, but will move up also. Parametric lines that you can create, just a parallel line, through points with an angle or with a relative angle. So many possibilities to define how these lines should behave. Next to that, we have the reference points. For example, here to put a bearing. This could be a bearing, or it could be a connection with a pier. It could be a lamppost, so you can add reference points to with that. The analysis model is being included here with the other colored lines. This is and this is used for the tendons. So if you access a point grid, you can still access the parameters here. A row of 7 or 2 rows. Sorry, you can see here 2 rows, and then in the other direction I have 7. So you can still control. Should even be controlled by a variable. Yeah, so let's say I want to here just have 5, for example. Then you see you can change this, of course, be applied to my geometry. So cross section, main principle, you have your parametrical line 3, which uses some of these points, and the relation between the parametrical lines will then be kept and will define how your. So we see here, this is linked to a variable, and I would like like to move. So you see here that this is moved, or sorry, linked to a parameter, height of the section. Define a height of the section, or the name that you can give, which has its own, let's say, default value, and then when you assign it metrical line, you just do this also here. You can say, okay, it shouldn't be assigned to any, or it should be assigned to the height of section outside of your cross section. If there is no variable set, then it's just a fixed line. You can modify it here, but you cannot control it. More detail, more depth to your model, that you will be adding variables to it. You don't need to have it, then you get a fixed model, but you can still modify it here. So if we check again the main girder box and we are in main girder box cross section. This is the girder. So if you check the cross sections, we see here and variation, then we can see what variables from the cross section are actually of the section, which just comes from the cross section. Actually, each one of them will be visible here. So you see web width, half, bottom, coming from your cross section. So if you generate it in a cross section, this will be automatically added to the tables here. You don't need to do anything. It's not. What you can do is define how the variables will be used. So here you can see this different, but now you can see actually there is a lot of differences. We can see this also in a 3D model. This is the default height. Where does this variation come from? How can I control this variation? We can see here that this the values are being changed. You can just set this right here. I can say this should be 5 meters, for example. 5 meters. I can apply. Let's say this should be 3 meters, for example. Everything should be 3 meters. Apply, and then if I regenerate my, I forgot to check, turn off the analysis calculation. So that's okay. Then need to wait just a couple of seconds longer. Now always be 3 meters. So you can control these variables just in this table with a fixed value. Interesting to do a fixed value for each one. You can enter all cells and then put some numbers in there. You want to be able to. We can see now this model here is being generated like this. Okay, so let's check these variations. Not within how it should be. So how can I control it? This is done with the variations tables. So cross section, which with parametric lines, you can set variables to assign variables to the parametric lines. They will just enter them as a table and just put the values by yourself. Or what's more interesting, the next step would be then to is a table. So if I would check this height of section, then we see here that we have this type of variation for the bottom of the cross section. It means the height of the section. So by station along the axis, get the different heights, 3.7, 5.2. So from this point to this point, 3.7 meters, and then from 5.2 meters. So you see here how it's generated. You see also which type of transition is used, linear or. So this table with the graphical representation that you clearly see how it will behave, I can variation in the cross section. So you can say, okay, I just added to one cell, for example. Let's say this one here, and then it will be. I can apply it to just drag and drop it on top of the column header, and then you will see now this will be generated stations will be calculated. So you don't need to define each station individually. Just from this station to this station, this type of transition will be, and then all these values are calculated. If you add a point to it, station to it, it will be automatically calculated what value it will table. So if I now will not forget to turn off these things here, I think this is enough to just turn. And if I regenerate, then my 3D model will be generated, and now it should be the original state again, like bottom, corresponding then on connecting with the peers again here. So now we have this height setting. So this can be done in this variation table, and let's say this should now be, and I will exaggerate a little bit so we can see the difference. This should be a value to it. This will be adapted. The variation also will be adapted. As everything will, so the tables will adapt and the 3D model will adapt also. So let's say regenerate, be recalculated, and will include, so now you see here 8 will include this variation that this is now changed. Also interesting is that Allplan Bridge has an open interface by going through a TCL file. You can read and you can just modify it. So if you want to have external access to this file, you can just say, I will save this project. Here, this is, let's say, 01. And I will also open it, this file, with and then you have all the descriptions here from the axis, from the cross-section, from the variations file here. So you see, okay, this is the axis, the profile being described, and here we have already the variations, so the height of so I can change this in a text file and put this again to 5.2, for example. So that means you can copy-paste this thing from other software or in this text file to do some optimizations, for example. Okay, so save the file, no need it anymore. This is this 8 meter, and import it. This file again, so just modify it externally. Do I want to read? Now my 3D model or the full model will be regenerated, and now you can see again that this is the correct height. So this can interface that you can use to change the values and adapt some elements of it without or just okay. About the tendons here. So we have the tendon generation section. That there is the tendon grid, the point grid here, and the tendons. You can choose what point will be used. So let's take a look at that. Actually, it seems there are redundant points, but this is because you have different stages, and you also have so probably stage 1 goes there, where you have the end of these tendons here, and then you have another in the structure for the next stage. Yes, so these tendons, multiple points, you can just choose which one you would like to have there, and then you have enough space for the other tendons to go in between. So you can also be, if you need more distance to it. I think we will see this here. Like at the start, they will be, or here in the middle, they will be very close together. Multiple tendons connect together, you have a bigger distance between them. This is also controlled by the variation. So you can define a tendon in different ways. You can set it through points without having the variation going on, with the height of the tendons, with the probably the distance between them in 2 directions. And this is what we've set here as an height, for example, and then you see the evolution of the tendon within the main girder. So at station 0, this is the height, and then it goes to 3 meters, for example, 3.6. So depending on this tendon height being variable like this. So this is something that you can get from a calculation, for example. Input. This is the spacing in the height, and then you see again along the length of the bridge that at the start, of course, where you need to have the anchors, the spacing is a little bit wider, and then the parts where there is no connection, no anchors needed, it's closely. So vertically, we have this 0.2 spacing, and then 10 centimeters, let's say in the bottom of tendons, and then above the piers, you have again more spacing, so there's more space between the tendons also. So this is what you control, the tendon grid. So same principle, if you check again the section, like you had with the parametric lines on grid, you can see the offset here, or spacing, is defined by spacing horizontal and vertical. And then the offset that we have here, there is no offset horizontally, but there is an offset vertically, where it's positioned so that it flows along the 3D model from the start to the end. Yeah, so the same, you can start a very simple cross section and add to it for the geometry, add to it for the tendon grid, and then add variation tables to see even to one of these tendons. Here you would like to have, like maybe depending on what kind of construction you want, at what point would need to be stressed. Do you need to have blisters, or where this web would be thicker so the tendon will still have access to the anchor and stuff. This is what we will check now. So for the tendons, let's say, so they will be used. Let's just go in the modeling of the tendons here. So we have the view of the take. This one, for example, here. So you see this tendon being high, and you can see also which point it uses. You can see it here in the cross section, and then you can go through the different sets. So if I look from that, it jumps from one point to the other point. So for each segment, and then you can check here where it's located, and so you can see it going through these points, and this is what the tendon will follow. You can still interact with these points, so you can even use this if you want to switch it from there to there. You can have, you still have full control over it at the end. An example that I want to show here, in the middle, for example, and I will zoom in on this number 4 or 5. Oh, I'll zoom in a little bit. So we see this, this tendon here, where it will be then going on the inside of the wall. So we see here it's still inside of the web, and I would like on the inside. So what point do I need? I can check here from the station point. You can see here this is this point, and now I can deviate from its position defined by the grid. So let's say this should now, and I always forget it's plus or minus, so 1 meter located there. If I regenerate, maybe this is a little bit too much. Let's say 0.5, can recalculate. Oh, sorry, there's the wrong So here you can see now that the tendon is positioned there. I wanted to show it. Definition. So there you can see also that it's now being positioned like this. It will still follow the grid. It's just that there is no need to define this in the beginning. You can change this afterwards depending on information that you gain, like anchor type or whatever this also in a detailed model. So you have full control over all these things, all elements and all parameters. I think this is enough here. Maybe is there some result for the 10? If I select a PDF document, we generate. I'm not sure if I did the analysis. I've done the overview of the 10 definition, and you can also see then where it's inside of so like a table and a schematic of this tendon. Same thing that I showed in the PowerPoint also for the. Okay, I think this is it for the overview. Maybe Siswanto, if there are some questions here, I can go deeper a little bit into this model for the.
Yes.
Yes, questions?
Yes. Yes, there is a question for the super elevation.
Yes.
Allplan bridge. Let's say you know that when you turn, you have a certain super elevation that you need to put. Can be designed in the Allplan bridge or in different application.
And you mean the value?
The value, right?
No,
Okay.
because I input the value in Allplan bridge. That means I can design something or under design something. This is up to you, because if you want to have the super elevation, then you need to have, for example, the surface set. In Allplan bridge, what super elevation in any way that you would like. So if somebody does the calculation, they say we need to have 3% here or 5% or 10%, model will be generated depending on these values. Yes?
Can you show how to create this?
Yes. So what you need for this is that you don't have to do this in the beginning. You can add this later. But the line which defines the inclination or the super elevation. So in this case, this is implemented, and you can see here this would be, or that makes it possible to define the super elevation. Yes. So you can see this is the line that can. There is also parameter set to it. So if you check here, we can see this is the inclination, and you can say, okay, it should be a fixed thing. Right now, this is just a definition. What is more important is that when you have the inclination, that you can control it through this. You have an inclination. I think this is then in degrees here, where it starts at your station at 50 meters, this value, 8 meters, this value. So it just goes from this value to this value to the end. And this is then what we will see in the 3D model. Also adapt this. So here we have the super elevation right now. Let's say I will set everything to 0. One should be 0, this one should be 0, this one should be 0. And of course, I can add new stations to it. Yes. So everything should be 0. Then the super elevation, oh, there will be no super elevation. You see now everything is just flat from start to end. And then you can again and say at the beginning I would like to have -2, -2, and it should go to minus something like this. So you can control with the different values at any point. So the thing is that you would not too many, like you have a straight line, you have a clockwise or a spiral, and you have a circle, and then for these points you need to set how the. But you have full control over it. So it can be on a straight line, for example, you can change from -2 to +. It's just that you need to input these values here. Model will take into account the super elevation that I've set. So we see here now this is -2 on the other side also. 5, everything will be regenerated. So it's just a question of adding the right value to the table. But it's you control over this. If he wants to input a negative or in the wrong way, super elevation, this is possible. Yeah, so it's up to him to do. That's the answer to the question?
Yes. Can you show ML, let's say, into the Allplan Bridge?
This will be shown tomorrow.
Oh, this will be shown tomorrow.
Yes, I will. Can quickly show it because then I will need to generate a model. But we have this prepared for tomorrow. So this is done by BIM Plus.
Okay.
So if you log into BIM Plus, access to a project. So you choose a project, and this is then the BIM Plus interface, which shows you have access to different teams, and then you can choose the one that you would like to use for alignment. I'm not sure if there is an alignment. And then you can say, I would like to import the axis. And then you choose axis, and you see no axis here. So you need to have an axis to be imported. So the thing is, this is generated in BIM Plus. Somebody uploads the axis, connect here to the project to download it, and then it will be used. The horizontal, the axis in plan and the profile will be used. You can have multiple axes that you import, and it updates the new revision of the axis included. You can also update it in BIM Plus. Sorry, in Allplan Bridge. So the link is down here. Yes. So this will be shown tomorrow.
Okay.
Other questions?
Jadi menjawab, sorry. Jadi itu bisa dilakukan di Allplan BIM Plus. Besok akan ditunjukkan oleh Mr. Stevens.
Yes.
Use Allplan Bridge to design runway taxiway of the airport. I don't think so. Yeah.
What do you mean with taxiway?
In the airport, you know that there is a runway, right? Like a road, yeah.
Yes.
Yeah.
Taxi for that? Oh, taxi, you mean for the airplanes?
Yes. Yes, airplanes.
I thought you'd be taxi for people picking, seeing for the airplanes.
Yes.
I would say if it's in general, it's just a big slap of access to it. I would say yes.
Okay. So it's possible.
Yes.
Okay. Next stage, can you are you able or will you show cable state bridge temporal, because I see last.
I can show an example. Yes, I will.
You want to show an example, or you want to show some example of the model that you did?
One model of the one model I did before. Okay. Some examples. I have 2 or 3 examples prepared that I would like to show after this here. Actually, okay. That's it, right? So
yep.
I will be going through a real step-by-step where there is already quite a lot of detail included, and I will go step by step to where we start really from scratch with the cross-section definitions, adding some variation to it. This will be in 15 minutes or something. Okay, so let's go to some. Oh no, sorry. I want to show, of course, first also for this. I will show in the end of the presentation actually the live link where we model something in Allplan Bridge, show it again in Allplan. But here I would just like to use this model and then see what we can do with this model in Allplan. Same model that we see here, imported from Allplan Bridge. And what is interesting is that you have control over what kind of element you can import. For example, just the main elements, main girder, the piers, like this stages can be imported. So these are things that you can then handle in Allplan to create visualizations or drop drawings. Remember yesterday there was the sweep functionality that I've shown, and it uses edge bridge. You can see these lines. These are actually the edges being generated in the ALLPLAN bridge model. Prefer, or there's a setting, you can transfer them to ALLPLAN and you can use them to create your rebar. So when you in ALLPLAN bridge, you don't need to define these edges by yourself. They are just transferred. So that, let's say, typical reinforcement in that section. So I have here a section for the bridge. I will just define a bar shape, not a of these, or how you can control these edges. So I just say I will create it here in the section. It will follow this edge, so here at the top, this edge, this one in the bottom here, and then this in height, in width, because it's getting a little bit thinner here at the bottom, and so follow also air here above the pier. So we have a lot of variations, and it's double curved also the axis. So we will use this bars along. So choose the bar, and now have to choose the axis generated by ALLPLAN bridge. So the main path is the main sweep here is. And now I will use the secondary or the other parts to define the geometry. So this one here, start to the end. So in ALLPLAN bridge, this is segmented, but you can select it easily all at the same time. So it's the same thing for the one in the bottom, and then you can see that it goes follows the bottom curve, and here the edge on the side. You can see this is also following this curve. So now I will create a 3D reinforcement along this axis and so okay, let's say change the, so this is now 1 meter. It should, and you can see here that this is now everything adapts quickly to it. So you see it follows the edge here at the fall. Yeah, so we'll make it a little bit bigger. So with just a couple of clicks, you ALLPLAN bridge to create reinforcement in it by just clicking the edges. Okay. Examples. First one would be this cable state. So this is not a real bridge. It's just a design based on existing bridge that has been reproduced in ALLPLAN. Everything that you see here is generated from ALLPLAN bridge except for the water surface. This was just something in ALLPLAN. But the railing, handrail, you have the cables, you have lampposts, you have vehicles. Everything is with this smart placement. So it can be quite detailed, and it's parametrically ALLPLAN bridge. So open, see if I have the project ready. I will get just the TCL. So import TCL. And so let's say yes, open the TCL. We have this model here. So what I would like to show here also is, or maybe the different part, what you see here are multiple axes. One for the bottom to define the positioning of the piers, I think, and I have a secondary axis. And imagine, which can take some time, but then there is a modification axis, or there is a variant axis, which is also interesting because you just don't two positions where this bridge could be created with two different axes. And then I can modify this to be able main axis 1, axis 2, and this is the bottom. And let's say I would like to have the other axis. So my girder, oh, this is the people placement. So you see there is in Allplan object being placed along the bridge. So this is with a variation, the train, the lamppost and stuff. So there are different elements in Allplan. Black dots, these are actually the smart placements. So maybe I can go into detail a little bit. This is the handrail. For example, a handrail, and this is where the handrail is positioned. So every station there is a handrail position. Lamppost, then we'll see lamppost or the persons. Yeah, so here you can see where, again, controlled by a table. Now let's just see here what happens with everything has been defined, like the cables. If I change the axis, so I have here my different elements. So the one is linked to axis, so I can choose a different reference axis. I will select everything except, I will select everything here. Axis 2, and the foundation should then be linked to this one in the bottom. Okay, so now if I regenerate it along the other axis here, yeah, so by just setting, and everything will be recalculated, will be regenerated, like all the position of the cables. This axis is different if you look from the top. So let's say the start is similar, but this is straight and this one goes to the right. But everything follows nicely. Yeah, so you can quickly change this again. Let's set everything again to the axis 1. Variants, variant 1, regenerate. Being regenerated again on the original position. Oh, didn't work. Like this. This is something that can be easily done. Okay, let's go to another example. And there. Yes.
Okay, one thing before. There is a question when you create bridge in Allplan segmented, but when you import to Allplan engineering, it becoming one. Yeah? Is there any way that you can make it more easier to the extent?
So there is the difference, let's say, between a general model and what you would like to see is. And if you define construction stages in Allplan Bridge, maybe go back to the examples, or maybe I will just take another example. So if you go back to the how the element will be split in different segments. So we have another example here. Let's take a look at the constructions, different constructions here, different phases. Oh, and that was not right one. So if we have these different phases, and each phase will be a different object in all, then it will just be one main girder. If you do it by this construction stage, and then this will be split. So I will now say, okay, we play here, and you will see the pier being generated. Maybe I can make it a little bit quicker here. So this is one segment. This is another segment. So each object will be its own element in Allplan. So this is a possibility, and then we will jump to the pause, or maybe a little bit more pause. So this object here, this will now be one segment because it has been defined in in the construct one pore. So I would say the construction stages for the modeling detail is where you define how the different segments will be created. Yes? Okay, go to the next example. Same things, based on an existing design of bridge and then just remodeled in ALLPLAN Bridge to visualize it. So here you can see looks a little bit like elevated highways that we see a lot in Indonesia. Maybe same meters or thing. I think that is similar to what I've seen. You have this special piers with the variables. You have also the variation of the deck, the height. So if I would open this here, okay. So then where you just have a cross-section defined, main cross-section of the bridge, for example, deck or two girders, but it can be actually constructed as in one sweep because the axis could be the same. Here we have a couple of cross-section because there is some variation going on. So if you check here, there is a variation. You can see it maybe a little bit more clearer. So there is a part where this is closed, there's a part where this is open, and then there's a part where you have another shaded but with different cross sections. So if you check the pier in the bottom, that would be this cross section. The pier at the top. So that would be this cross section that we have here, where it's split, where actually this is also split on this side. And then again, depending on the parameter that you use, I'm not sure, for example, here also the angle. And depending on how you set this, you can see here at the top all four. I do define one here that all 8 edges will follow this angle. So there are multiple ways to define how the geometry should react to it. Okay, let's go to a step-by-step example. Okay, so I will create a new, I will maybe first show the open. So is this one here? It's very simple, but allows me to show all like this, where we have one main girder, not too complex, with one pier, and then we will. So we'll just start with a new, let's say. So there, new project, okay. Or import from a project where the axis has been uploaded in. Okay, then you can say, I would like to have another segment. In this case, I would like to add a spiral with a specific curve divided by the radius in the beginning, and at the end is 0 because it will connect with a straight line, and the length will be 40 meters. And then I will add a straight line to it, and this will be then 35 meters length. part one. I need to have a profile because I need to have a 3D axis. This is just a 2D axis. So they make a profile. So first point, zero height, not necessarily to set anything. Point will be then, let's say, in the center, so and the height will be 1.5 meters. And I will not set any radius right now. I will to the ends. So okay, then we would have an axis like this. So let's check this in. You see, this is like it's curved, but it has from the side, of course, this gap that I don't want to have here, or this gap, this section where you have one going to the other. So I need to modify this, and you can do this while you create this, or you can easily. Here I have a rounding type, let's say intersection of tangents, and I will define now a radius of. Then you see radius being generated. You see also station points. They will be added to the axis, so you can easily recognize them. Yes, so it's now smoother here also at the top. So this is a cross-section. Cross-section, new cross-section, name, define anything. And now I will create here. It's nothing special, just starting by the main to the left and also here to the right. So this is the width of the deck, and let's say I have deck thickness. And from the bottom, and now it gets interesting because I can define what should be the reference. Let's say if I choose I will choose, let's say, a height from 1.65 meters for the deck, and I will continue a little bit, and then I will show later the width of the girder in the bottom, 2.2 meters, something like this. So now we have an outline already. Boundary. So boundary, just click the points that you need to have. Boundary. This is a boundary. To be able to generate something, I need to make it a structural unit. So in this case, boundary, and then you will see it being filled with blue. That means structural unit. The other one would be a load unit. That would be green, and like for the side. Change this, just click, and then we can see how it reacts. So we see the bottom can change. What happens now if I So you see the bottom will go down also. I'm not sure if this is how it should be. This is something you can still control afterwards. Should be different. I want my reference line to be the actual main reference line. That means if I change this, right, if I would change the thickness of the top slab, this will have no effect on my bottom. So this is something you can choose. If this needs to be linked, then certainly you can do this. I would say in this case it's not necessary. Maybe I can change the value here to just for representations purposes. So this would be the fixed distance that I set here. And I would like to have the bottom slab following this line and not the top line. So these are things that I can play with. So right now we have the cross. To be actually show something here, we need to assign the cross section to the axis. So for this we create name, anything, main girder, choose the cross section, and then you see here the preview, and you can choose from what, and then the one that you click will be highlighted, and you can enter the value here. So this is station 1. First to the end, and then you can also enter this value. If you want to have another station point, you can just click anywhere and just write the value. can choose the steps. So step would be that there is a segment, or let's say a station created each 5 meters. Later you can do it in one step, or let's do it just now, is fine. And then the 3D model will be generated here. For each 5 meters we have a station to the end. To visualize what you see in this 3D window, what type of elements you would like to see. Okay, I see here that something I forgot to mention in my presentation, the traffic case, if I'm correct, live loads are included, so you can have your bridge deck and then lane scanning, which you should have. You can create these vehicle trains or load trains where you assign them to these lanes to have this dynamic. Okay, so let's continue here with the geometry. So the axis is okay. We have now our section, main girder, but I don't want to open section. So you can still modify all these things. So go to the section here, and I would like to add now also our parametric lines. So 0.35, this one here, 0.35, and here from the bottom, that choose the right line. If I set the bottom edge coming with a relation to this one, that means it will not follow section. So 0.3, that means as soon as this changes, you see the other line will follow this line. Additional boundary on this point, for example, like this. Okay. Boolean operations, like we've seen yesterday with the modeling in Allplan, just in this cross section. So the main cross section minus this boundary, and now I get that. So if you regenerate, then you will now have this open element. So very quick to modify an initial design and then add detail to it. I think this is really the power also of this parametric design. You start with something very basic, and then you add, as soon as you know, or as the design evolves, you add more detail to your design or to your cross section. So okay, let's continue maybe here with a pier. So I create a new cross section, and this will be also simple. Let's say I have again 2.2 meters. Just in the other direction, and a width or thickness of the pier 1 meter. 1 meter. Create a boundary. Okay. Just go that this is also a structural unit. Okay. Now, before I can assign a reference point, and the pier will be attached. In this case, the top of the pier will be attached. Can be with an offset somewhere. Let's say in the middle I have one, so that would be in 55. If I would like to add it here, I need to have reference in the cross section. So in this section, main section of the girder, I need to add reference points. So reference points can be used placement in Allplan to put a lamppost or a bearing, for example, and can be used to make a connection with another element in Allplan bridge. P1, pier, name, you can change this name also. Oh, there was one too many. So point. So this reference point, one, you can change it. It should be placement in Allplan. You can define the 3D model, and then you can see now there is this reference point, and this can be used then for the generation or the link of the pier with this, the peer, new peer, select the reference point. So select this reference point here, your section, and let's just click somewhere. And here I will say I want to have it with 0 would be then the reference 5 or something, so that gives me a half meter for a bearing, for example. Can be less, can be more, can be 0 if you want it to be. Okay, the bottom, let's say, will be, so I just click somewhere and with steps of each 3 meters. So that won't have something like 5 steps. So here we have the different steps. So we have now a pier, very simple, and a bridge deck. So if anything changes, that would also have influence on my element. So let's go back maybe to the axis. Will be 300 meters, but should be minus 300 meters. So just going the other way. If I regenerate now my model, we should see that this here should also follow. Yeah, so this is this parametric definition and link between the different elements. Okay, so this works for the horizontal axis, the vertical axis. So you can go always back to your initial design, the first element you created. It can affect on the other things that you do. Okay, now next step would be this variation. So the height of the deck in the section, I need to add a parameter. So let's first add this variable to it. So the length. And now I can define this through this line. So if I don't add it to anything, you see now something strange happened because the main value was 0. So I just set it to 1.9 again. Main height 1.9 and taken over from this parameter. As soon as I regenerate my model, if I check the variation tables, then you will have this value right now. And now this is what I've shown also in the beginning. You can do this. Should be, let's say, I will exaggerate a little bit, should be 5 meters. And then you can generate it, and then we will see that it's not correct, but you can have control over these values just by adding 1 parameter to the section. So this is now the height. 8 meters. This is not what I want. I would like to generate it, and I would like to also make sure that here the pier is not like, the connection with the pier is not like this 1 point. It has a flat surface or fairly and the bearings. So I will add now additional stations to this point. So in the main girder, the station at 52.5 meters and another one at 57.5 meters. So that means if I check here, 2 more stations added to it. They're not yet used because I didn't define the parameter yet, but now you can see you have an additional station, so no need to add them whenever you model something. And here I will now define the table for the height of this section. And the height of the section is defined by length or the station point along the axis, and y is the value, the actual value being used for that with 1.9 meter. And the second point will be 40 meter because it will, to the next point here, is like this 52.5 that I just inserted. 50, and this will be then 2.5 meters. So this is what this variation that I would like to see. And then again, of about 57 5 meters between the 2 on top of the pier. So and at the end 110 should also be 1.9. So now we see we have something like this, gradually or parabolic. So I can set the transition from point 40 to the next point 52. You can set at the beginning like this, and then the next one from 57 to 70 I would like to be horizontal at the end. So now if we check the 3D model, nothing will happen yet because I need to assign my table to this variation. So you can use it just within the section to control multiple elements, for example. You can assign fixed values to it, or both of them at the same time. So I can still just drag and drop here. You see it will be applied, but now I can still say, no, this should be still control over each station and each the variation value at that point. So here you can see now a variation table, 1.9, 2.5 where the values are entered, but in between this is calculated from this parabolic values. So if I will be automatically calculated. So if I would now apply, then we will see here that my 3D model gentle variation where we have this 1.9 meter going to 2.5 here. And similar for the pier, and then so pier, I first need to assign a variable to it. Pier width, and the pier width default value is maybe 2.2 meters, and then I can assign these parametric lines. Now you see I can change one by one. If I assign them and assign the other one to the parameter, then you can control multiple lines at once. So if I change this one now, you will see the other one will react also. Or variation that is assigned to these lines. So next step here, again, you use the same name, doesn't need to be, but easy to understand. And then I start at -15, starting point, the bottom of the pier, and the value here is not 2, but let's say 1 meter. And then at -6, at the top, which was -0.5 or -0.5, for example, here, that was correct, and 2.2 meters, for example, 2.2, and again, you can set it like this, or it should go from this point, for example, at the beginning, like this. It could be the other way around also, so you have different possibilities. Now, we just need to check if these values written here, so -15 to 6, and then at the top 0.5. Again, variations. Variation table will be included, or the parameter will be, variation will be included, and I'll just drag and drop, and then you will see here also being calculated, and our 3D model will be adapted. Yeah, so we've done some couple of steps, going from axis definition, say plan and profile to get the 3D axis, cross-section definition, apply it to the axis, pier cross-section definition, variation tables to control how this element behaves. Maybe one small thing for the tendons. The cross-section, you can add a point grid, click add it to a reference line, define it the tendon points like I've described before, to add them and to create tendons point and also the grid definition. Okay, that's it for this step-by-step example. I have one thing. This is the interaction between ALLPLAN and ALLPLAN Bridge. So I will set this up. This one here. Maybe there are some questions, Siswanto, that me to answer?
Yes, 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 yes.
Okay.
Can you create abutment? Yeah?
Yes. Yes, certainly. That what we showed that yesterday, right? The abutment. I did some free-form modeling. Oh, you mean all?
It's, yeah, in
Yes,
ALLPLAN
yes,
Bridge.
certainly. Yes, yes. Sorry, the misunderstood. Yes, certainly. You can define this in ALLPLAN Bridge. Any included that have this abutment. Let's see if I have here one that I opened recently. I think this one here. So you can define this. It's just another, and then within the transversal axis, yeah, you see here, for example. So you see this is then the abutment being generated. Tendons being included, you can see here all the tendons. So this is then segmental cost, and this is then the abutment. Yes? Okay?
Yes, yes, yes. So you can create it.
You have a road or a bridge defined by a center axis, an axis on the side, which define the geometry. That can be important, but this is the axis. So this depends on the design. Some roads are defined by central axis and an axis on the side. Yes, this would be possible. Okay?
Okay.
So let's go to the last example.
You can go ahead.
Examples fly over Kerensheide. This model right here. Move this a little bit. And then different faces. So this one, or this one and this one. Yeah, doesn't matter. This segment, and maybe I make this a little bit smaller. So I have this prepared, and everything we see here, the tends with also the lamppost and the guardrail here, this is all generated by ALLPLAN Bridge. So there is nothing modeled in ALLPLAN here. And you see this is now straight and flat. No specific design here. And I will open ALLPLAN Bridge already here, ALLPLAN Bridge from this model. And what I would like to do is super elevation. The pier, you have this one pier rotated 45 degrees, at least the foundation. Something else, there is this, the different lampposts are being set. So some modifications that we've seen in the other examples, and now would like to update. So this model that we have here, so this is ALLPLAN Bridge model with all the tendons included. There are quite a lot of tendons included. And you see this is now straight model, and I would like to get it to the state where it should be and just show as an example how this works to get this model updated. Yeah, so this is now the link between ALLPLAN and ALLPLAN Bridge. So in ALLPLAN Bridge, I will do some changes. So we will change the axis because we see now this is fairly straight. So I will change the curve to have it come to 300. So it's a more visible curve. And I will also change the profile, because now this is flat, and if we check in ALLPLAN, yeah, this is flat, but if we check in this one here, then you see that the height is also being changed. Let's see if I can give this also a different, multiple viewports maybe, that we can see this also here. So animation view, yeah, you see that there is a curve and that it has super elevation and that it's not flat. And there also exchange with this one, and then here. Okay, so yes, we have now the different views here. So we need to get this curve and the super elevation in, and the heights also for the profile. So at the start, let's say this should be now 8 meters, and the end should be 5.5 meters. And I would like to have a curve here in the center, which is a radius of 3000, like this. Okay. Now let's maybe update this change already in ALLPLAN Bridge. So you will see now it's curving here, and then also the height is different, but all the tendons, they just follow, right? So there is no need to define anything. If the correct definition has been done for the tendons, then everything will just adapt to it. And you can see this can be quite complex, because above the pier, they're close together, but then they spread out again. And this is defined in these variations. So in variations, we have for the tendon a different profile. So horizontal offset, I think this is then a vertical offset, is the spacing between them. So you see this is the curve for the tendon height. And then we have another one where there is a spacing. So depending on the station, it will be closer, so like 40 centimeters apart, or say 25 or 65 distance. So there is at minimum 25 distance, at maximum 65 centimeter distance. This is what we see here. So this is the closest point above the pier. And then in the middle, there is actually distance of 65 centimeters. So all these parameters have been defined. If something changes, they will just adapt to it. So these are also tendon groups. You see they also are straight at the end to connect with the other tendon. So this is very detailed design, and just is being transferred when you do the changes. Okay, now let's do the super elevation. In the cross-section, here, there is this weight savers, and there is also then the angle is included for the inclination. So if I go to the table here, I can set the inclination here. So the 3D model is still flat. I will set the inclination or super elevation to be at the start -5. At this point, it will be -3, and in the end it will be 0. Yes, so we have, I think this is above the pier, we have some slight change. So if I set it here, then now we will see the super elevation being generated. Yes, so here we see now this, all the, again, for all the tendons, this is adapted, so they keep their position within this deck boundary or boundary box. The same thing for the pier. So for the pier, let's say I have the pier, and here for the cross section, I will define that this has also this angle, so -3 there, and for the other pier at the end, I will also say this is minus, and then 46. Where do these values come from? You will be able to see this when you check the inclination of the main girder, for example, or the variation. At this point, you see this inclination where the second pier is, for example, with this value. So you can reuse that for the inclination at the top. Okay, let's say there is one more thing I need to do here. In the final design that we have here, you can see that this, and this is because there are highways crossing in different directions below it. This foundation is a 45 degrees rotated. Yes, so this can still be easily done. So right now it's just 90 degrees or perpendicular to the axis. I would like to rotate this, and I will do this here in the pier. And the variations of the pier 2. So set this to minus 45 degrees, 45. So I will rotate the foundation block in the bottom, independent of the pier. Yes. Okay. So now let's regenerate. Okay, maybe one more change. Before I do this, we also have the lampposts in Allplan here. You see there is on the car. I will not touch the car, but you see the lamppost. Maybe there are too many. I would just like to have a lamppost here, and not this one here, not this one. So one less lamppost. And in Allplan Bridge, this has been defined by variation here. So you see here along the stationing, I put a lamppost, and I don't want to have this one here. So you can just delete the value or write 0. As you can see, it just, oh, this is just should be 1. So now there is 1 lamppost, 2 lampposts less. Regenerate model. Not much changing here except for these black arrows, right? So now there is one here, there is one in the middle, one at the end, but there is no intermediate anymore. So I think all the changes have been applied in Allplan Bridge. So let's update in Allplan. Update here, and now we'll see the model being updated. So this should change. We have the piers, which should be different. Assign them again. So if you check here, in like a titanium texture, this is concrete. The road has a surface assigned. This is not something you set in Allplan Bridge. You can assign materials, but it's in Allplan to make it good for visualization. So when this is updated, all the clicks change, and this model will then, with one click of a button, will adapt and will be updated with all the changes done in Allplan Bridge. Of information that is included. This is quite a detailed model. This can take up to a minute or 2 minutes to when it's ready. That also the, say, painting of the road will change. So of the road deck, it will change. The car position will change. The lamppost position will change. We will have the bearings that of the tendons that will adapt. So everything will follow this this change. Yes,
Stefan.
Yes.
Untuk menjawab pertanyaan tadi, ada yang menanyakan bagaimana untuk memasukkan lampu jalan, bagaimana untuk guardrail dan segala macam. Allplan Bridge kita hanya memasukkan referensinya saja, posisinya, terus nanti di dalam Allplan Engineering akan dirubah menggunakan perlu dipanggil di dalam Allplan Bridge. Stefan, I'm explaining that you are actually calling up a block in Allplan Bridge, right?
Yes, this is the direct link for the lamppost. The tendon, the anchor heads also, they are all objects in Allplan, and you assign them in Allplan Bridge what object you positioning. So yeah, no need to reset anything, but you can define your extensive library in so here you see now all the changes have been applied. So just one click on, so you have the deck that changed, you have the being changed, radius doesn't veer off too much because it's almost at the side. So here also the bearings, they adapt to it, the being rotated, lamppost, number of lampposts has changed, and the position also. So everything is generated from ALLPLAN Bridge. This is very nice because if you want to have a different bridge, a little bit quick visualization, there is nothing you need to do. Everything is generated. Come from to answer that question. You can have your own library, and in here you see this door just bearing blocks and these tendons. So maybe let's look just a little bit into the tendons. Turn off everything. So one element. Yes.
Stefan, can you show how you are using how you create the marker?
Oh, yes, yes, okay, yes. I will first go through this here, this last thing, so go just a couple of minutes more. So we main girder with the bearings attached to it, okay. You have the guardrail. There's an element which also you will have the solids coming from ALLPLAN Bridge, and then the smart placement, like the bearings, they come from. They are same for the guardrail. So the rail itself is generated by ALLPLAN Bridge, and then the smart symbols, they're being placed. We have the pier elements. Oh, there the piers. Yeah, just one pier. So this is different elements. Let's say the weight-saving blocks here, they're also included because they are at specific positions. So this is also something that you can include. Girder or element in ALLPLAN Bridge will be an individual element in ALLPLAN. And then we have the tendons. Let's say I would like to focus here. So the tendons, you see, they align very nicely with the depending, and they follow the and set if the tendon needs to be straight. You see this is almost horizontal, the other one goes a little bit down. These objects, they follow automatically. You define for a tendon, for example, let's check here just one tendon, and then you define which one is used, I'll just select that one here. Is used. So anchor with a different type, with a start and end, because there is a different anchor. And then in ALLPLAN, this anchor is placed in starting anchor. So depending on, of course, how the tendons will be stressed continuously. So here you see end and start being connected. The last part, so we have the side. This is then a different kind of profile also in ALLPLAN Bridge Generation. There's a cross-section. So here, based on the same variables, so for this you just copy the original cross-section and then define, and then you just define the shape around it. Can be easily with a chamfer round or like this. This is for the, let's say, the road is the last point here. Guardrail road. They are built up of, is there also a smart symbol? Yes, that would be the car and the lamp. Depending on how it's generated on Bridge, you can have many different elements. So here, this will probably be many different elements. So you see, this is how can you play with that? Let's say you would like to give this a different color in ALLPLAN. For everything here, just turn on the elements you would like to have, and this one, depending on how you different color, and then they could look different. They could look different because this has now, just say here one. I think I picked it wrong. Can give them a different color or different texture. So let's say I would like to assign a different texture to it, visualization. In ALLPLAN, the attribute-wise, so adding information, visualization-wise, they will be kept. So let's say I want to make this concrete. I want to make this concrete, for example. Then the next update you do from ALLPLAN, this information will be kept. Yes, so you can do the visualization in ALLPLAN or do the update in ALLPLAN, everything will be changed, but the visualization that you created already will be kept. You can do then the parametrical changes, but still keep the visualization in ALLPLAN. Okay, I think this concludes.
Alright. Okay.
Yes, it seems to work.
Oke, ini untuk menjawab tadi ada teman-teman yang menanyakan contoh-contoh project yang sudah digunakan, yang sudah menggunakan. Jadi di sini ada beberapa sampel dari project, tentunya nggak bisa semuanya. Dan tadi juga ada pertanyaan apa perbedaan antara ALLPLAN Engineering dan ALLPLAN spesifik dia untuk mengerjain modeling. Jadi dia bisa mengerjain jembatan hanya menggunakan ALLPLAN Engineering tanpa apa ALLPLAN Bridge. ALLPLAN Bridge lebih ke arah dia bisa melakukan desain, dia bisa melakukan karena dia sifatnya parametrik. Kalau kita gimana jalannya berubah gitu ya, seperti tadi ditunjukkan oleh Mr. Stefan, sekali kita sudah melakukan pemodelan, nantinya mau diubah ulang. Kelebihannya begitu. Jadi di sini bisa dilihat beberapa karena masalah waktu juga. Jadi ini hanya beberapa sampel daripada masih banyak project yang nggak bisa kami tunjukkan karena sifatnya masih tender. Jadi mungkin untuk sekedar memberikan gambar, ini dilakukan di ALLPLAN Engineering. Jadi ini stasiun high speed rail juga, architecture juga. Ini untuk jalan mungkin bisa dilihat ini projectnya adanya LRT untuk buku sebelah kanan adalah gambar detailnya. Ini gambar penulangannya. Jadi kalau ALLPLAN Engineering, ini contoh-contoh daripada project. Ini contoh daripada Ini ada ini juga suatu jam dan segala macam bisa dipakai. Bahkan ini untuk jalan juga. Jembatan kecil juga ya. Jadi beberapa contoh yang memang saya ambil yang sesuai. Ini precast building. Dari saya mungkin cukup seperti itu. Mungkin Pak Nova dari PUPR bisa menjawab, Pak. Pak Nova. Arif, can you give Mr. Reza the audio? I do.
He should have it now.
Pak Reza, sudah bisa? Audionya, Pak? Ayo. Seri kedua pada hari ini bersama ALLPLAN. Silakan ini link feedbacknya diisi lagi ya di browsernya masing-masing, diisi. Kemudian saya ingatkan supaya penulisan namanya itu depannya itu besar-besar semua setiap huruf ya. Misalnya saya Reza Munawir, R-nya gede, N-nya gede. Kalau misalkan mau supaya adalah akademik, karena nanti nama yang dimasukkan ke dalam link feedback itu adalah nama yang digunakan untuk sertifikat. Kami tidak akan melakukan penggantian kesalahan penulisan dari Bapak Ibu peserta semuanya, jadi ini tanggung jawab Bapak Ibu semua ya. Karena kita ini bikinnya kayak hari ini udah ada satu-satu harus melayani penggantian akibat kesalahan buat penulisan dari Bapak Ibu sendiri. Jadi tolong diperhatikan banget, nulis kita kasih kesempatan sampai jam 4:05 ya, sekitar 15 menit. Kemudian tadi namanya tolong benar yang rapi, karena kita nggak akan melakukan spelling, nggak akan melakukan merapikan tidak. Jadi kita itu yang langsung dijadikan untuk sertifikat. Untuk hari ini kami mengucapkan terima kasih PT Piranti secara teknologi ya, yang menjadi satu-satunya representatif di Indonesia. Juga kepada hari ini siapa ya Pak ya, yang ini Pak Ramon ya, yang want to show Stefan, oke. Sudah presentasi for your presentation today. Like something
related to our job title. Nah, itu
I think you mean. Yeah. Like the opportunity for to show today the ALLPLAN Bridge Solution. I think we were capable of showing everything what we wanted to see. And now looking forward to webinar, what will be tomorrow about BIM Plus, our collaboration platform. We saw very good numbers again of interest. So yeah, it was our pleasure. From my position here, I want to thank Stefan for his very clear presentation, and I want to thank Mr. Siswanto for also showing some reference projects we have seen in Indonesia, and of course the POPR for hosting.
Yeah. We're excited to welcoming you all for tomorrow webinar. Pak, ini boleh Pak muncul semua fotonya barangkali biar saya screen capture buat apa diberitain di media sosial kami Pak.
Fotonya maksudnya Pak? Atau tampilan orangnya Pak?
Tampilan orangnya, share webcamnya.
Are you done? We show your video?
Oh, we cannot share together like Zoom, no?
Possible, but it's possible. But maybe we can send you. We will send you the pictures, which is better because I'm afraid that Stefan is using a shot. Yeah, Stefan.
It's okay. It's totally fine. No, it's totally fine. Could you please share your webcam if you don't mind?
Right now?
This is
Ramon, yeah, you want?
If you
Ramon, you can show your face.
Like this? Okay.
Hello. This is for our media social Instagram. So all the activities of our unit are published in our social media for this past 2 months because we conducted like so many kind of events. Okay. Thank you so much for ALLPLAN. Okay, I will take picture of us. Screenshot. Just wait. Wait a moment. Okay. Yeah. Maybe I will use another computer. Okay. Jadi rekan-rekan semua, Bapak Ibu, rekan-rekan semua silakan sambil menunggu kami foto-foto. Ini bisa mengisi linknya ya. Kita tungguin. Kalau bisa Bapak Ibu ngisinya jangan lebih dari 1 kali ya kalau bisa, karena kita rekapannya jadi banyak banget nanti. Sebentar Pak Sis ya, ini saya lagi buka PowerPoint untuk mindahin screen capture-nya. Kalau dalam waktu dekat ini pasti ada kegiatan apa lagi Pak? Di dalam bulan
kita bisa lanjutkan dengan pelatihan sih Pak sebenarnya Pak. Pelatihan kan mungkin akan membantu ya. Jadi kemarin kan bicara juga dengan Pak Cakra, pelatihan teman-teman SMK dan segala macam itu akan kita lakukan Pak. Segera mungkin.
Ya. Pasti kalau misalkan ALLPLAN ini digunakan untuk anak-anak SMK itu mungkin nggak sih Pak?
Bisa Pak. Kan itu untuk kita kan ada student version Pak. Ada student version yang bisa dikelola oleh sekolah juga. Kemarin sudah sempat dibicarakan juga untuk teman-teman SMK, jadi nanti akan ada student version yang mereka bisa pakai untuk mengerjakan project juga.
Jadi SMK itu dari Direktorat Dirjen Vokasinya Pak, itu saya Direktorat SMK itu ngajakin ini Pak, kolaborasi karena mereka mau masukin BIM ini ke dalam kurikulum anak SMK.
Betul Pak.
Karena kan ada itu, Pak, sekolah desain informasi pembangunan bangunan. ALLPLAN udah pernah Pak ya?
Saya udah pernah kerjasama, cuman memang ini kan nantinya politeknik dan segala macam. Kalau SMK kita punya pengalamannya di Singapura Pak, dengan ITE ya. Kalau di sana kita dulu punya pengalaman dengan ITE, jadi bisa diajarkan di sekolah SMK gitulah kurang lebih kan, SMK yang kita sekarang. Jadi pada dasarnya sih bisa Pak. Jadi kita nanti bisa tinggal nunggu kelanjutannya, karena kemarin setelah Pak Cakra ada meeting dengan Dapatkan ya. Jadi tinggal pelaksanaannya seperti apa nanti kita lihat lagi Pak. Intinya sangat memungkinkan.
Kalau misalkan saya udah tanya sama mereka itu kan mereka masih lebih fokusnya di ini Pak, di building. Itu bisa juga Pak?
Bisa
ya?
Pak.
ALLPLAN ini untuk building.
Di sampel project saya tadi sengaja saya masukin building Pak supaya Bapak bisa lihat. Jadi itu project-project di Indonesia Pak.
Oh ya maaf Pak, tadi saya baru join. Ya, saya sebenarnya udah tahu juga sih yang kemarin kompetisi BIM Wika.
Ya betul, di kompetisi BIM Wika kan ada Pak. Ini ada beberapa contoh-contoh project dari teman-teman karya juga yang saya tampilkan. Jadi separuh building, separuh infrastruktur gitu Pak. Jadi nanti bisa kita follow up lagi karena masih banyak bangunan yang lagi di tender kan ya. Kalau sifatnya tender kan belum boleh dilepaskan gitu ya. Tapi kalau yang mereka sudah menang gitu kan boleh ditunjukin Pak. Kalau sifatnya masih tender, masih rahasia, jadi masih disimpan.
Ya,
prinsipnya
kode ya.
Prinsipnya saya dengan PUPR juga Pak. Waktu pengerjaan jalan tol Sigli ya. Itu ada PUPR sama Adikarya ya, sama HK ya. Itu saya ada videonya juga. Cuman tadi nggak saya tampilkan karena memang waktunya Pak. Cukup panjang videonya.
Ini tadi ada teman-teman saya juga Pak dari Bina Marga, Bina Marga yang dia notif ngasih tahu saya kalau mereka ikut webinar ini. For your information, jadi kalau Bina Marga itu udah tahu Pak ya yang bangun jalan jembatan Pak?
Ya banyak Pak. Jadi di Bina Warga kalau nggak salah saya dulu ketemu di acara ya. Jadi ada Pak siapa waktu itu ya, Pak Made.
Oh iya, Wayan itu
ya.
saya juga.
Ya, jadi memang sudah sempat ada pembicaraan Pak. Nanti akan di follow up lagi ya prinsipnya. Jadi banyak Pak dipakai di jalan tol. Jadi nanti ya memang perlu minta bantuan dari PUPR ini untuk difasilitasi, jadi kita bisa jadi intinya untuk institusi kita fully support, right Ramon? For the institution we have full support, right?
Absolutely, that's agreed within the organization. So yes, we have full support.
Di Jerman tuh hampir tiap tahun 2 kali Pak itu ada satu acara sampai jumlahnya ribuan Pak. Itu jadi kalau nanti kita ikut di dalam itu kita bisa presentasi apa yang kita kerjakan dan segala macam. Tiap tahun mereka punya event. I think have an event for the student, right, Ramon?
You mean
a few thousand people are coming, right?
In the headquarters, we have it's called a summit for international students. Yes, this year, of course, due to the different, but yes, it's the normal approach.
Jadi di Munich Pak Reza, untuk khusus untuk student Pak. Jadi dekan atau teachers atau student mereka punya summit. Cuman karena COVID aja tahun ini ditiadakan, tapi tahun depan ada lagi.
Do you have any like competition, like global competition for students? From ALLPLAN?
There is a thought create one, but I have to come with the details on that later to you. I cannot present that. We are working on delivering a student competition.
Because as I know, this stuff and also Graphisoft, they conduct like they gather like competition for students. Yes.
Yeah.
Yeah,
Yeah, we are aware of that. And actually, the question from we get that question. Thinking of delivering that, but I cannot give any details on this moment. So, but it's something we.
Ramon, we've just concluded a visual scripting global competition.
Yes.
Well, and that was open to everyone.
Yeah, true.
Kompetisi juga.
Ya, kalau ada itu menarik banget Pak, supaya ya ini kompetisi gitu kan menarik banget Pak, yang menarik banget.
Lebih semangat Pak.
Karena ALLPLAN ini menurut saya software. Kemarin kita webinar sama beberapa kontraktor BUMN, Pak Sis, sama diantaranya sama apa? Kalau Adi ya, tadi Adi ditunjukin ya sama Pak Sis tadi ya videonya ya. Itu kalau nggak salah juga udah di share juga sama mereka. Juga. Tuh komen saya lupa dari perusahaan yang mana, mereka bilang ini kalau untuk masalah riba atau apa punya. Karena mereka open game ya Pak. Jadi juga banyak juga ini setiap software ini mana yang mereka pakai dan apalagi Wika ya, Wika itu ALLPLAN semua kayaknya, ya banyak ALLPLAN.
Ya nggak cuma Wika sih. Sama Pak Cakra kemarin, tim itu kan lebih ke arah terminologi Pak, bukan software Pak. Kami percaya ada teman-teman, jadi intinya kita buka sebanyak mungkin supaya teman-teman masyarakat bisa lihat semuanya Pak. Jadi mereka bisa pilih sesuai dengan kebutuhan. Kurang lebih begitu. Ya, mantap. Buat Bapak Ibu, rekan-rekan semua, ini mungkin bisa mau menghubungi Pak Sis langsung, apa boleh? Maksudnya untuk sudah ada di chatting sih Pak.
Oh ya sudah.
Ada di chatting Pak. Kalau mau menghubungi bisa hubungin kontak @pirantisarana.co.id. Jadi dan juga yang nggak memungkinkan dilakukan di webinar akan kita jawab lewat email juga. Kita akan kumpulkan semua pertanyaannya, nanti kita jawab.
Baik.
Kalau waktu kan nggak mungkin kita jawab di webinar semua Pak.
Iya, betul. Terima kasih. Jadi buat semuanya tadi udah disampaikan sama Pak Sis ya, nanti akan dijawab pertanyaannya, dan Pak Sis ini orangnya luar biasa, jadi kalau dikontak kayak kalau ini malam apa dibalas gitu sama Pak Sis.
24 hours. Mas Reza juga jam 3.
So Mr. Ramon, I sent I chat Pak Siswanto like in the middle of the night. He's very what is it? Sangat-sangat ini Pak.
Yes, I can tell you a little secret. So we but working with Siswanto, it actually means there are no time zones because he always replies. I remember.
Luar biasa. Jadi Bapak Ibu semua jangan khawatir. Habis ada program-program ini juga Pak Sis ya. Ada webinarnya, ada pelatihannya juga. Gitu, nanti bekerja sama dengan PUPR juga. Nanti buat teman-teman kita akan ada pelatihan, kalau misal tertarik banget nih, harusnya sih tertarik banget ya kalau udah ngelihat presentasi webinar dari ALLPLAN ya. Oke, ini sudah 15 ini untuk webinar kita pada hari ini. So I think 15 minutes are left for the participant to what is it, to register, to fill the feedback. Ini Pak Sis kok masih freeze ya?
Saya tadi sempat hilang di satunya Pak, lupa baterainya Pak, tapi saya...
Oh ya udah, oke baik Pak Sis, ini kita tutup aja ya Pak ya. Baik Bapak Ibu peserta semuanya, webinar, so thank you so much. Terima kasih banyak untuk kehadirannya pada hari ini buat mengikuti webinar offline. Jangan lupa besok masih ada dan hari Jumat masih ada seri kelima. Besok itu tentang BIM plus, lusa dan Kamis dan Jumat ini berkaitan dengan bagaimana penerapan BIM ini dikaitkan dengan teknologi universitas. Ini juga sangat-sangat menarik banget ya, karena ini bagian dari kalau misalkan yang di proyek ataupun yang mungkin punya peserta Bapak Ibu yang dari perusahaan-perusahaan itu aja terus ya, diikuti terus sampai hari Jumat. Itu saja mungkin dari kami. Kalau misalkan ada hal yang kurang berkenan, mohon maaf. Untuk link sertifikat kita tutup sesaat setelah webinar ini berakhir. Untuk ini sertifikat akan kita bagikan tautannya informasi. Kita upayakan banget lebih cepat sebulan. Tapi kalau bisa nanti kita upayakan ini kurang dari sebulan. Kita share kami @sibima konstruksi, Instagram @sibima konstruksi, Facebook sibima konstruksi. Kalau untuk mau mengulang-ulang lagi tentang webinar ini, nanti mau dilihat-lihat lagi, silakan nanti kita upload juga webinarnya ini, recordingnya melalui kita upload di sana. Itu juga kita sudah upload di sana video-video webinar yang kerjasama dengan tentang bagaimana bisa diterapkan di proyek konstruksi. Silakan itu dilihat videonya. Pinka udah berapa, Pin? Bukan nggak? Sebentar ya, saya cek dulu ini udah semua atau belum. Oke, ini 107, 807 people who already fill the feedback link. Thank you so much. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. So bye bye. Thank you, Mr. Ramon, Mr. Stefan.
Bye bye.
Thanks to all guys. Thank you.
Bye bye.
Thank you. Bye.
Guten Morgen or Guten what?
Guten Morgen.
In Germany.
Real good. Bye bye.
Okay. Thanks everyone.
Bye bye.
Ini.